Hi, in this video we will do some examples for implicit differentiation. Well, some equations are given and we are asked to find dy dx. Remember the steps. We have to always start with differentiate both sides with respect to x. So while differentiating, here we have quotient rule, derivative of x plus y times x minus y minus x plus y times the dx of x minus y over x minus y squared. The right hand side, well, this is 2x minus 0. And then while then differentiate the terms we have derivative of x is 1, derivative of y, we just write dy dx times x minus y minus x plus y, and then again derivative of x minus y is 1 minus y prime or dy dx, and then x minus y squared in the denominator equals to 2x. Well, that is basically step 2. When we're differentiating a term involving y, we use the chain rule there. Now step 3 is solve it for dy dx. Yes, so here I can start expanding the numerator and multiply the denominator to the right hand side, so it will give us x minus y plus x dy dx and minus y dy dx. Then here we get x minus y, then plus x dy dx and y dy dx. This is left hand side. Right hand side is 2x times x minus y squared. Very nice. So here let's see if we can do some simplification. For example, see this, this guy and this guy, they cancel each other. This cancels that one, and then the left we will get negative 2y and plus 2x dy dx equals to 2x x minus y squared. Now take 2y to the other side and then divide 2x. There we get 2x x minus y squared plus 2y, and then divided by 2x. That's basically what we were looking for. Dy dx is x times x minus y squared plus y over x. So that's the first example. The second example, again, an equation is given. We have to do step by step. Step 1, differentiate both sides with respect to x. Then apply the differentiation rules. So the first one is the product rule. So we see dx of x cubed times y cubed plus x cubed dx of y cubed plus d dx of x times y squared plus x d dx of y squared, and then minus d dx of y, and right hand side this is just derivative of 0. Okay, then this is 3x squared y cubed plus x cubed. This basically we are doing step 2. Wherever you see expression in y, apply the chain rule. This is 3 dy dx y squared plus, this is 1 times y squared plus x times derivative of y squared is not just 2y. You have to apply the chain rule and multiply it by dy dx minus this is dy dx itself. Well, let me simplify a little bit. I mean, just 3x squared y cubed, then plus 3x cubed y squared dy dx plus y squared plus 2xy dy dx minus dy dx equal to 0. Then here step 3 starts. We have to solve for dy dx. We have 3 terms which have dy dx. Take everything else to the other side. It will be minus 3x squared y cubed minus y squared. And in the left hand side, you just factor dy dx. So it will be 3x cubed y squared plus 2xy and minus 1. Then as a result of that, dy dx is minus 3x squared y cubed minus y squared over 3x cubed y squared plus 2xy minus 1. And that is how we find the derivative of a function implicitly defined for this example here. Well, okay, there's part 2 of this example which says find equation for tangent line to the curve given by an equation. Okay, remember for the tangent line, m is basically dy dx, the derivative, when x is 2, y is 1 for this case, and the point is 2 and 1. If we find that, then it's done. We already differentiated this function, so let me just pick that from there, copy, and then we have it here, paste. Okay. Okay, we have this function. We have to plug in what? X equal to 2 and y equal to 1. That will give us the slope here. Then we have 2 times 2 minus 1 squared plus 1 over 2. That will give us 2 plus 1, 3 over 2. Slope is 3 over 2. Point is 2, 1. So y minus y1 equals to m times x minus x1. Then y minus 1 equals to 3 over 2 times x minus 2. Okay, then write this as 3 over 2, slope and intercept, minus 3 plus 1 is minus 2. So that's the tangent line to that curve. For this other one, we have to find m again, and we have to find then evaluate. So for that, we do the implicit differentiation. X squared plus y squared equals to d dx of 2. This will give us 2x plus 2 dy dxy equals to 0. And then from there, 2y dy dx is equal to minus 2x. And from there, you see that dy dx is going to be negative x over y. Then the slope is dy dx, but we have to plug in x equal to 1, y equals to negative 1. And that gives us negative 1 over negative 1. And that is 1. The slope in this case is equal to 1. And then point is 1, negative 1. So y minus y1 equals to mx minus x1. This is y plus 1 equals to x minus 1. And that gives us y equals to x minus 2. That is the tangent line to the curve x squared plus y squared equals to 2 at 1 and negative 1. So these were the examples we had. Again, the steps you have to take one by one, and if you want to evaluate after you differentiate, you can just evaluate the derivative at the given values.